equations. And when I do the derivative, I always change them because that's easier to follow the rules, yes? So let's write it right here. Y equals x to the 1/3. That's what cube root means. If I wanted to take the derivative of that, what would it be? 1/3 x to the negative 2/3. Now, without a calculator, let's see if we can calculate the value at the point 8, 2. And so how do we get that, though? So how do we manipulate? This thing is going to scare us without a calculator, right? So let's see if we can manipulate it a little bit. This is the same as 1/3 x to the 2/3. Would you guys agree with that? You flip, so the 1's up top, the 3's down below, now this is down below. Now this is the same as 1/3 x squared raised to the 1/3. Would you guys agree with that? Exponents raised to exponents, you multiply them. Something squared raised to the 1/3 is the same as to the 2/3. Yes? Which is the same as 1/3 x to the 1/3 squared. Both these are the same. Would you guys agree with that? Eve, do we agree with that? Exponents raised to exponents, you multiply them. So using either of this information, can you tell me what the derivative value is at the point 8, 2? Without a calculator. See if you can do it. Using either of these at the point 8, 2. Try it without a calculator. Yeah, in this case, this one's probably going to be easier. Because otherwise you got to square 8, which is 64. And then you take the cube root of 64 is, well then you got to think, it is 4. So it would be 4 times 4 is 16, times 4 is 64. So that would be 4. In this case, you take the cube root of 8 first, which is 2, and then square that. In either case, it's 4. Does that make sense? And in both cases, then you multiply it by 3, and you get a slope of 1/12. On the original graph, we have the point 28, slope of 12. On the inverse graph, on the flip of the points, you flip the value. And that looks right here, because this looks like it's still positive, but looks like it's more of a shallower, like just over 1, or just over 0. Does that make sense, you guys? What's good about that is, like, you can use this information to figure out other information about the inverse without actually doing anything with the inverse. But here's the trick that you would have to do. If you wanted information about the inverse, you'd have to say, okay, I have the point 28. You know what I'm saying? Or if you wanted an x value of 8 on the inverse function, I want to know the derivative at an x value of 8 on the inverse. What you'd have to do with your original function is say, okay, the x value will give you 8. Because you want the y value on the original function to be 8 for the x value on the inverse to be 8. Does that make sense? And if you can figure out that point, if you can play that game, then you just have to take the derivative at this point and then flip the number. And you can do the whole problem without even looking or without doing anything with the derivative function. Does that make any sense? Yeah? What you can also do now is, what if I didn't know how to solve this for y, like we always do? Well, you don't have to. How do I take the derivative of x equals y cubed? How do I take the derivative? Okay, so I flip my x's and y's, but I'm stuck on this, and I'm like, man, I don't know how to solve this thing. It doesn't matter. You don't have to solve it. Because what it wants is, what's the derivative? How do you take the derivative in terms of x equals y cubed? You have to chain rule. What's the derivative of x? 1 equals. How do I take the derivative of this? Who's home? derivative of what's inside, which is dy dx or y prime. Does that make sense, you guys? Okay? Now, I can solve this for y prime just by dividing by 3y squared. Does that make sense?
Yeah.
But it's like,
Oh, that makes so much sense.
but it's weird because here's the same, this is the same graph. This is the same equation. It's got two different,
Could you plug in y equals?
but one's in terms of x and one's in terms of y, and you'll get the same value for every single point. So let's try this one. This one, so these are the same. This is both the inverse, this one and this one. I just solve for it differently. At the point 8, 2, the derivative value is going to be 1 over 3 times y squared is 4. It's 1 over 12. You get the same thing. Does that make sense? Two different ways to solve for what the inverse function's slope of tangent line is at this point, A2. Okay? But again, if you know how this one works, you wouldn't actually have to even look at it. You get all of your information off of the original graph for an inverse graph. Because sometimes you don't know what kind of kooky time you're going to be living in, you can't get it. Does that make sense, you guys? And again, the game would be, here's the game. If I wanted to know some inverse function, I want to know what is the value of the derivative, the slope of the tangent line, and x equals 8 for this inverse graph. What you can do is, on the original graph, that x value is the y value. So if you can figure out the point where this is the y value on the original graph, then you can take the derivative of this thing at this point and flip it to get the value of the derivative of the inverse function at that flip point. Does that make sense, you guys? Okay? So that's for any function. This stuff kind of comes up from time to time. Just interesting to think about where you don't even have to look at it. So let's do this. What is the derivative of sine? One more time, everyone together. What's the derivative of sine? What's the derivative of cosine? What's the derivative of tangent? What's the derivative of cotangent? What's the derivative of secant? What's the derivative of cosecant? Again, all the cos are negative, yes? Cosine, cotangent, cosecant are all negative. The other three are positive. Okay? One more time. Derivative of sine? Derivative of cosine? What's the derivative of tangent? What's the derivative of cotangent? What's the derivative of secant? What's the derivative of cosecant? Make your flashcards and make sure those are in your brains, okay? And again, something to keep in mind though. If I want to take the derivative of secant 3x, the derivative of secant 3x is secant of 3x times tangent of 3x times, now I'm looking inside. Does that make sense, you guys? It's secant tangent, that's what we say, but it's secant of something times tangent of something. Don't forget that. Okay, you guys? A lot of people made similar things like that on the last quiz. So we have some function